So now we'll talk about intersection of lines. And here's our first problem of the day. Find the point of intersection of the line for f of x is equal to 2x and g of x is equal to negative 3x. Then we need to sketch the lines. Okay. Okay, so now let's begin. The solution of this problem is, first of all, take your equations, label them 1 and 2. fx is equal to 2x plus 10. We're going to call that 1. And we're going to call g of x equals negative 3x to be 2. So now what we need to do is we need to compare 1 and 2. Now, when you compare 1 and 2, all we're doing is we're just setting the right sides of each equation equal. Let's make a slight correction right here. This should be 2x minus 10. And now we've got 2x minus 10 is equal to negative 3x. So now we'll go and solve. So 2x plus 3x is equal to negative 10, positive 10, which means we have 5x is equal to 10, which means x is essentially 2. So now, once you've got that, x equals 2, we're going to sub x equals 2 into equation number 2, since it's the easiest one to sub in. So we end up with g of 2 is equal to negative 3 times 2, which is equal to negative 6. So now that we've got that, we can say the point of intersection is 2, negative 6. So remember, when we say g of 2 equals negative 6, we're saying that our x value is 2 and our y value is negative 6. And so now, how we're going to plot that? Let's do that. So now, what we're going to do first of all is we're going to plot the first point we know on our graph, which is the point of intersection. So we're going to punch in 2, negative 6, and we'll put that point right here. So that's our first point. The next thing that we have to do is we have to go back to our original graph. F of x is equal to 2x minus 10. And you'll notice that you have your slope is 2x and your y-intercept for this thing being negative 10. So we can use for equation number 1 up there, negative 10 as an idea of where this thing is. Now that I have that, now we can draw our line. Y is equal to 2x minus 10. And the reason why we were able to do that is because we knew what our y-intercept was and the intersection point. We just used those 2 points to draw a line. Make sure you label it as well. You can write it as y is equal to 2x minus 10. Or you could have written it as fx equals 2x minus 10. It doesn't matter to me. Now, for the last graph here, let's call it equation number 2. G of x is equal to negative 3x. its y-intercept is 0. And then its point of intersection, remember, was this point here, 2, -6. You'll notice that I'm labeling all these important points as I go along, and then graph. And so now our final equation is y is equal to -3x, and there we go. So this problem that we have here is about using a thing called tangents. So determine the equation of all tangents having the slope of 4 to the circle. X squared plus y squared equals 17. So x squared plus y squared equals 17 means I have a circle on this graph. I'm going to draw it in green. That looks like this, and it's centered at 0, 0. But the distance on our graph, the r value on our graph is r squared is equal to 17, which means that r is equal to, since it's a length, we're only going to take the positive root of it, 17. So it's the root of 17 for our basic circle. Now we're going to take that circle and we're going to put that evidence on the graph. So if I'm looking at this top point here, from the center up, it's root 17. So the point on this graph here is 0, root 17. So now that I've got that point labeled, we can use that to our advantage. Now, it's asking us to find all the slopes where, all the lines where the slope is 4. So I'm going to sketch 2 lines on this thing so that it touches in. Let me show you what a tangent is. So a tangent is a line that literally just touches the outside edge of our equation, or the equation of our circle. And clearly, if there's one on that side, there's one on the other side. We're going to call this line L1, and this second line up here, we're going to call it L2. Now, the basic equation for each of these lines is given by y is equal to mx plus b. So we'll use that, and let's say that I was saying the following. I know that for line 1 and line 2, m1, so the slope of line 1 is equal to m2, which is equal to 4. Now, I'm going to draw a line here that represents the perpendicular line to L1 and L2. So I'm going to try this. It's not perfect, but I have my line here. There's my line. And it's perpendicular to both of those. The point here, I'm going to call this P in the corner. And this one down here, I'm going to call it point Q. So here's what you know. We need to sketch a line that is slope 4, right? But it's perpendicular to the line PQ. Okay? So here we go. Let us see if we can come up with an idea of the slope for PQ. So the slope for PQ is going to be, well, -1/4. And how do I get that? That's because the following is true. M1 and M1 is perpendicular to the slope of MQ. PQ actually. Now, the best part of this solution is the fact that this line goes through, the fact that this line here goes through the origin means its y-intercept is 0, right? So that means the equation for the line of PQ is given by y is equal to a quarter x. Oh, sorry, negative 1/4 x, please. Make sure you write y is equal to negative 1/4 x. So to find the points P and Q, you're going to have to substitute PQ into our original equation. So let's do that. So like I said, we're going to find this by subbing. So we'll start with our basic equation, which is x squared plus y squared equals 17, and we're going to label that equation number 1. And then for the second equation, we're going to use y is equal to negative 1/4x and that point, and we're going to use number 2 as our equation. So now we're going to sub equation 2 into 1. And by doing so, you take y and just plug it in to wherever y is into equation 1. So now we have the following: x squared plus bracket negative 1/4x squared, and notice it's in brackets, is equal to 17. And now simplifying. So now you're going to get x squared plus x squared over 16 equals 17. And then what you're going to do is you're going to bring the common terms together. So this is going to turn out to be 17x squared over 16 is 17. And now we get rid of the 16 by multiplying both sides by 16. And you're left with, that cancels that. And now you're left with x squared with a 17 in front. So you have 17x squared is equal to 272. So now that we've got that, we're going to divide both sides by 17, which means x squared is equal to 16. And when you take the square root of 16, it has to be plus or minus, which means this is x is equal to plus or minus 4. Now that I have that for my final solution, what you have to do is take all this information and we substitute sub x equal either 4 or negative 4. I choose 4 into our first or second equation. So I'm going to sub it into my second equation because it's the easiest one. So I sub x equals 4 into 2, and we end up with y is equal to, say, -1/4 times 4, which gives us y is equal to 1. Oh, wait a second. Please make a correction. This problem here, when we multiplied -1/4 times 4, you should have gotten, instead of 1, you got -1 as our final answer. Y is equal to -1. So now, substituting into the other equation, you get that. And in that case, y is equal to 1 when x is -4. So recall, when we were looking at the beginning of the problem, this is what we were looking for. We were looking for the equation of all tangents with slope having slope 4, right? So when we solve for this, we're going to use those points that we were starting with, that we figured out, and find the b values for each equation. Now I'm only going to show you one of these equations, solutions, and then I'll show you, and then you just go and calculate the last one. Okay, so now the points. So the point P is going to be 4, -1, and Q being -4 and 1. So now let's say I want the line that has m is equal to 4, but has the point P of 4 and -1. Let's quickly calculate. So we start with this equation, and then we use x1 and y1 to be 4, -1, and we end up with this. Now distribute the 4 into this bracket here. And we end up with y is equal to 4x minus 17. And so that's our first line. Now, similarly, for m equals 4 and our point Q of -4 and 1, we end up with y is equal to 4x plus 17. And we're done. Those are our two lines that we were looking for. And you'd say, therefore, the two lines are ... You know what to say. Your homework is going to be these problems here, 43, 45, 47, and 50. If you want to try an extra problem or two, so this is your extra challenge, 50. But you can also do, for extra work, number 49 and 59. So if you're done everything else, do these. If you need more work. So let's call this more challenge. And we'll move on.